So for just like before we start, this lesson is gonna be a lot more like problem solving and like there's gonna be a bit more lecturing and less like there's still gonna be discussions, but it's mostly gonna be lecturing and then we do example problems and then through these example problems, like either me or one of my TAs will go around and then help people with their questions. So we'll probably just skip a lot of the examples because we don't have computers to type on, but I'll do like some of the lecture. Also, this is day 2 of week 1. So this assumes that they've already learned day 1 of week 1. And we will start off with like learning materials for the most of the first week. And in the second week, we'll start working on our like projects. So these projects, they'll be like, I think some people have done games where it's like they catch the apple. I remember we played some last year, but yeah. So this is gonna be homework recap. So last week's homework, they were supposed to make a podium and they were supposed to make a house using the Turtle Python library, and we're just gonna like you guys clearly haven't done a homework, but I'm gonna assume like most kids will have done a homework. There's definitely gonna be some kids who like haven't done the homework or skipped it or forgot about it, and there's also gonna be people with like issues in their code. So this is my solution, but before we get into this, like in the actual class, I would go around, we would check people's work. We would like, especially for people who have bugs in their code, we'll help them with discovering their bugs and then we'll help them fix those. And then this is mostly just to go over in the end. I know the quality is really bad. I don't know how to fix that because I think I just have to use the app because PowerPoint and web, it makes the photos like really bad. But here's my solution to the podium question. Let's just go step by step. So first we're defining some functions. So our first function here is draw a rectangle, where we have our where we want to put the rectangle, and we have the width of the rectangle, the height of the rectangle, and the color. Because when we're making a podium, we know we want to have three rectangles with different colors. We want to have first place, second place, and third place. And here we have draw podium, which is the function that actually completes our entire thing. And our first step here is to create the background, which is used with turtles.screen. Our next step is to actually make the turtle. And then we create our podium dimensions, because each of our podiums, we want them to have a set width, and we also want them to have different heights though. So what I did here was I first drew second place, because second place on the left, and it's gonna be the second tallest. So I drew it with negative step width, which basically moves the turtle one width to the left because we want to leave space for the other two rectangles. And then I draw this with a step height, with like a normal step height. But then for first place, since it's in the middle, we want it to be bigger, right? So I start it at x equals to 0. And what this does is, this starts it where we see the leftmost point of the middle podium. And we do step height times 2 because we want this one to be the biggest, the tallest podium. And finally for podium 3, it's the same as the other two. We started from, instead of negative step width for the first podium, we started from regular step width. So it's 2 widths behind it, which guarantees that they're all the same width and they're all placed the same. And we draw the third rectangle. I know this is like probably a bit complicated because like you guys weren't here when we did the first lesson, but I'm assuming they know what these rectangles are, and then we also have a TA just going around helping them. So yeah, and if you have any questions, just raise your hands.
对，我有一个建议啊，然后你就会说那个 turtle full， 就是一会儿往前一会儿往后，你有没有什么动画效果可以加进来？
I don't have it on this computer right now because I have a different one open on my turtle Python thing. But I would have it open and then we could run the program. Like we can run it with this. But that one I have something else open right now.
你需不需要一个 whiteboard?
Not for like this class, but like in general, if there's a whiteboard in the room, I can use it.
Okay, 我们是有一个这么大的 whiteboard 可以用的。
And then we'll move on to the second homework problem, which I would also assume like some people have done it. This one is just a normal house. And as we learned before, we learned how to make squares, we learned how to draw rectangles, and we also learned how to turn at angles. So this problem just combines all three of these skills that we've learned. And this function, I just copied from the last one. It's the same thing, same with draw rectangle. But I created a new function called draw triangle, which we've also done in our last class. But basically what this one does is creates the triangle for our roof. And we set these as where we want the triangle, we want the base length, and we want the height, and we also want the color. And what I do here at the end is I make the function of draw house. We set the screen to light blue, but you can set it to any color, there weren't any restrictions. And then we'll first draw the base of the house, and then we draw the roof using the triangle, and then we finally draw the door using a draw rectangle. And that's it for homework, but we'll move into what we're doing this time. So we're gonna do today we're gonna learn about loops and variables. So first, when we drew the square last week, we noticed that we had to move forward, and then we had to turn, and then we had to move forward again, and then turn, move forward, turn, and then move forward. Does anyone know an easier way we can do this with less steps?
You can make it repeat, so you can put it in a loop.
Yeah, we use a loop. And what a loop basically does is it repeats the steps within the loop, and it repeats it for a set amount of times. So loops are a main part of coding. You'll see them basically in everything because it simplifies code so much, it makes it so much smaller. And it's also appearing in real life. I want you guys to all clap. Clap, clap again. Clap again. Clap again. Clap again. So it's getting kind of annoying now, right? But I could have just said clap 5 times, and you guys would still clap the same amount of times, but it would be so much more efficient. That's pretty cool. So loops actually have everyday usage too. We probably use them every day. Yeah. So this is an example. In our actual class, they would run this on their computer, and what it basically does is this basically just makes a square. Alright, just trust me on this one. This makes a square with those loop. And yeah. So this is gonna be our first example problem. Jim lives in a 2-story house, but he can't get up the building because he doesn't have stairs. So what he wants you to do is design some stairs for him. And your hint is to find something that's repeated and use our newfound knowledge of loops. Yeah, we'll skip this, but I do have, this is actually what I have open on here. So this is just an example of something you can write. They can write other things, but what this does is it does and that's pretty cool. Because these are 4th graders, I think. Wait, for timing, I think we would spend 15 to 30 minutes on homework recap. I think we'll spend 10-15 minutes on this. And then now we're gonna learn about variables. So as you saw in the for loop, we use for I in range 4. Now, what does I mean? Does anyone have an idea of what I could represent? It's on the slide. What is I? I is a variable, guys. And a variable in coding, it's a way to store data. And what a variable does is it can be changed in the code when you're executing it. So this is also really important for coding. It's probably just as important as loops. And what we can do is we can use variables to store a specific number, store value. For example, if I want to store how many cows I have on my farm, and I can set a variable cows equals to 5 because I have 5 cows right now. But let's say one of my cows die. So I could do cows minus 1, and it'll change the number of cows I have to 4. So that's pretty cool. This is another example where we can use it with juice. Let's say we have 3 cups of juice, or 2 cups of juice. And in 1 cup, we currently have 1 liter of juice. But now we want to pour 3 liters or something from another cup into this first cup. Then we could just increment the variable, cup 1, or in this case I used x as the cup. But we can just increment x by however many liters we add to that cup. And it'll keep track of the amount of juice in each cup. So let's code this one. So we're not actually gonna code it, but I'll explain it. So we have two cups, A and B, and right now they're both empty, so we can set A and B equals to 0. And then at any time, as we learned before with print just outputs a certain thing. So when you print a variable, it'll just output the value associated with that variable. So print A or print B will print however much juice is in each cup. So now I want you guys to write code that pours 2 of the units of juice into cup B, and then print out what's in cup B, and then pour 3 more units of juice into cup B, and then check again. And we'll give you like a few minutes to do that, but what you should get is you should get 2, and then you should get 5. Because it starts off at 0, and once you put 2 in, it'll be 2 in there. Wait, you guys all know this. Now, I want you guys to try this again, using your newfound knowledge of loops and variables. And what this does is it prints out a spiral. So why does this work? Well, we store values in our variable I. And the way a for loop works is it increments I by 1 until it reaches a certain range. I think it's on the next slide. So on the next slide, there are 3 types of for loops that are commonly used. The first one that we're talking about is right here, where I starts at 0 and then it increments by 1 until it gets to b minus 1. That's when it stops. So the way this works is I starts at 0. So first it moves forward 0, and then it turns to the left 90 degrees. And then I becomes 1, so it moves forward 1, and then it turns again 90 degrees. And basically, I as a variable, because the value keeps changing within our code, and we can still use that variable with whatever value is currently in it. So the next example of a for loop is we do for I in range A to B. So let's say we don't want to start I from 0. We want to start I from like 3 and maybe go to 5. Well, then what we can do is we can do for I in range 3 and 6, as I will start at A and it'll increment by 1 until it reaches b minus 1. Well, let's give an example. What if you have a machine that can only pour 3 liters of juice into a cup at one time? Then you would have to increment by 3s, right? So is there a way to increment by 3s instead of just like actually writing down 3 lines of code? You can do for I in range A, B, C. So I starts at A and it'll still go to b minus 1. But instead of incrementing in sets of 1, it'll increment in numbers of C until it stops before B. So like we'll see an example. Let's do for I in range 3, 6, 2. I want you guys to write down what that would print out, or what that would print out. And we'll just skip this.
Right. It's going to print out 3 and 4.
No.
No?
No. 3, 6, 3, 6, 2. What should 3 or 4? Well, it should print out 3 and 5 because it increments in sets of 2 and it starts from 3. So it'll go 3 and 5. And the reason why I won't go towards 7, because 7 is actually bigger than 6 and we want to stop at 6. So that's, yeah. And now this is practice, and this is where we're going to spend the most of our class. This is a pretty difficult question. And basically what we're doing here is we're going to take a break beforehand, but then this we're going to be working on, and the way you solve this is you basically first move down the handle and you use a for loop to draw the teeth of the cone. And basically what we would be doing is we would be having them write the code, and then we would be giving them hints as we go along, and then we'll be going to help them. Right? Yeah. That's probably it for the seconds. Oh wait, never mind. We have a bonus question. This one's, I thought this was last week. At least not. Oh, this one you just draw a polygon, and it also uses loops because you want to turn it at the same angle each time. And that's what we would be doing for the rest of the class. Yeah. Thank you. 我有问题，我有问题，我不能做个问题。好，我
我是觉得就特别有意思，虽然我不是很听明白了，但是我觉得特别好玩儿。对，就是我就是觉得你的那个什么，比如说就是 student 的互相之间的这种就是这种交互啊什么的都特别的好，然后整个节奏也把握的特别好。然后我就是可以建议，就是说能不能够第一是放缓速度，第二是在最开始的时候就开始加上一些炫酷的一些东西，先把小孩子的兴趣吸引起来。因为最开始你要开始讲知识的话，就会我觉得对比较小的小孩来说的话，可能最开始你多给他展示一点效果。我知道就是 X Camp 很多小孩在做过一些很有趣的那些动画或者是一些东西，就先给他们展示一下，哎，我们最后可以先画个饼挂在那个地方，就是我们最后可以做到什么什么样子，然后就很有意思。然后我觉得可能这个是比较那什么的。第二个就是那个 coding 的字儿有点小，对吧？
Yeah. That I need to fix. I think if I use the PowerPoint app, I think if I use the app, it'll make the quality of the images better. At least that's what I got when I was searching up. But I'm using Word right now.
对，然后我觉得你有一个环节特别好，就是你让那个小孩现场来填扣的那个，我觉得那个特别好。咱们之后是会有一个系统吗？来做这个事情？
Yeah, they'll have like a系统 for homework, like a website.
Okay.
I think it's hard. Like there's only a certain amount of lecturing I can do. Like a lot of their learning is gonna be through doing the examples. Because like that's when we can really have them write it down, and that's when we can really give feedback. But like we can only explain like what a variable is to a certain extent. They won't know what it is until they actually start using it. And also I think that's a good point. I think for a hook, because we have our last year's projects on here, so I think I could show the last year's projects. We can let them play it.
对 ，OK， 我没有意见。
这个需要每个孩子每天都要带电脑来是吧？
对，需要有电脑。
挺好的
，yeah.
反正我觉得就是我家老二就在code mining 的上嘛，是 mining code 还是 code mining？
code 是 future。
OK， 然后他挺开心的，就是一个课上排档一课呢，就是 Roblox 那个老师教他们怎么设计 Roblox 那些东西，他还挺喜欢的。我觉得确实像安娜说的，就是交换着来是最好的，对，这样子就不会太对。
So the students are also different grade, 4 through 7.
Yeah, but it's mostly gonna be younger.
Each give them varied assignments.
No, I think it's mostly me because the class is like an intro to Python. So like either way, they're all gonna be coming in with like a similar level. I think they might. I'm pretty sure most of the kids in this class are on the younger side. I don't think there's any 7th graders in Python 101.
Yeah.
So they might have a bit different like learning curves, but they all start the same.
特别棒。谢谢大家，然后请大家把那个所有的分都打好了，然后交给我。